A quick look at the laws of exponents. We will just limit it to the basic rules. So let me write down there and say laws of exponents. As I've indicated, we will just limit it to the basic rules. Maybe let's say law number 1. It tells you that when you have a base, maybe to the exponent of letter x, as long as you multiply it by another base to the exponent of, doesn't matter whether the exponents are the same or are different, this will be equals to, you no longer have to write 2 of the same bases, you just write 1 base, but what you do, you add the exponents. So that's what the first law says. So maybe let's talk about law number 2. This one, it talks about when you divide the same bases. I'm using letter B so that it reminds us of the base. To say when you have that letter B, maybe let's say you have again, okay, now let me say you have y, which is being divided by that same base b, and then we've got x. The law says in this case you are having that base being to the exponent of y. This time around you minus that x. It's different from that one where you add their exponents, because in that case you are multiplying the same basis. Maybe while we are still on this one, please be aware that that being divided by that, it is the same as you having base to the exponent of y over base to the exponent of x, which is equals to, again, that same thing. So just be aware that sometimes when it's given as that division, it might be better for you to rewrite it in that format because it's easier in that way. I will indicate as I do some more as to why I'm saying it's better when you do it that way. And then the other one, it says, let us say for some reason you have a base there, maybe it is to the exponent of x, and then outside you have y. So it's a base raised to a power multiplying by that power on the outside. So this is the same as that base having these exponents multiplying each other. So you have x multiplying that y. So remember, those exponents can be numbers, it can be letters, it can be a number which is attached to a letter. It doesn't really matter that much, but this is more like a formula or a rule that you will apply. So maybe something very much important that you might be interested to know is that anything raised to the power of 0 is 1. So you might be having, let's say, y, as long as to the power of 0 it is the same or equals to 1. That is why I ended up saying anything. It doesn't matter what it is, but anything raised to the power of 0, it's equals to 1. So it doesn't really matter that much whether you have 2 plus p, maybe minus y squared, the whole of that, as long as it's raised to the power of 0, it is equivalent to 1. That's all that you need to be aware of. Very much important on that one. So now, maybe let's just try and look at some examples. Maybe that being example number 1. Let's say for some reason you are given, it could be k to the exponent of 2, and this is being multiplied by another k to the exponent of 3. What we know is that it should be equals to, you just write 1k, and then you have 2 that you plus it with 3. And this will therefore be equals to k to the exponent of 5. That's how you apply the law. You just don't leave it. You don't just leave it at k. It's to the exponent of 2 plus 3, but you need to continue to add 2 plus 3 because those you can work them out. So let us say you have x to the exponent of 2 divided by x. This is an interesting question. So what I said was I used to just rewrite it as x to the exponent of 2 over and then say x. But most importantly, because you are dealing with the loss of exponents, you need to make sure that every letter is raised to the power of something, of which in this case it is an invisible one which I'm writing there. Just so that when I apply that law, it will make sense to say it will be x to the exponent of 2 minus, what are you minusing there? You are minusing 1. Then it ends up being x to the exponent of 2 minus 1, which is 1, and then you can just leave it as x. The reason for that is because there is an invisible 1 there. So that should be the end of it. So maybe let's look at another example which is related to the law that I've taken you through. So you might be having, let us say, it could be any letter that you can think of. Let's say maybe d to the exponent of 2, and then that I will multiply it by 3. So it shouldn't be a complicated one. You have d, then you have 2 that you multiplied by 3, and this should be equals to d to the exponent of that times that, which will be equals to 6, and that is the end of it. Okay, another example. Let's say you have, it could be 3 to the exponent of 0. So for the fact that it is raised to the power of 0, what did I say? You will equate it to 1. Very, very much important on that one. Okay, it doesn't end there. Maybe let's look at some more examples. What can I think of? Maybe let's say you have 2 to the exponent of 3. Maybe let's say this is divided by 2 to the exponent of 2. So here definitely we know that you are going to have one base, and then you have the bigger exponent, you minus that small exponent there being 2, then you end up having 2 to the exponent of that minus that. Definitely it is 1, and then you can just leave it as just 2. That is the end of it. So that means when you punch that on your calculator, it should just give you 2. Let me show you how tricky a question may be. Not necessarily tricky, but you may be given, let's say, 2 to the exponent of 3, which is being divided by, what if is 2 to the exponent of 3? What you know is that you have one base because they are the same, and then that minusing that, then you end up having 2, which is to the, that minus that, definitely it will be 0. Then what is 2 to the exponent of 0? Just like that one of 3 to the exponent of 1. Even this one, we just said anything to the exponent of 0 is 1. And that should be the end of it. Maybe let me add 1 or 2 more examples. What will be the example number? Okay, example number 7. I hope everything makes a sense up to this point. So now let's see, number 7, what if you are given, okay, let's say you are given s to the exponent of 2 close, and then that to the exponent of 0. Okay, what did I say? I said the law says you take this, you multiply it with that one on the outside. You can still say s to the exponent of 2 multiplied by 0. So what is 2 times 0? Definitely it is 0. It therefore means it is equals to 1 because you end up having a base raised to the power of 0. So it's not limited to this type of a question. You can still be given, let's say, okay, s again is fine. We can say 2 to the exponent of negative 4. So it's not necessarily always going to be a positive value. So again, what you know is that the law, you say that s, you take that 2, you will multiply it by that negative 4. That's all that you know. And you end up having s. What is 2 times negative 4? Definitely, if you punch it on your calculator, it will give you negative 8. And that should be the end of it. Maybe example number 8. Let me think of something. Okay, let's say you have p to the exponent of 2, and this is multiplying p to the exponent of negative 1. This is multiplying y to the exponent of 4. So according to the law, or the laws that we have gone through, what we know is that our main focus should be on the bases. Then once we know the bases that we are going to be dealing with, then we will know what to do with their exponents. So it is this base which is the same as that base, and those are multiplying each other, and when they multiply each other, we combine or add their exponents. So that means we've got p, then after having that p, you have that 2, which you need to add it with that negative 1. This one being y, you can't do much about it because that base is not the same as that one that you are dealing with. Definitely when you say 2 plus negative 1, it will give you a 1, multiplying that y to the exponent of 4, and that should be the end of it. Or even if you just write it as p, we know you've got invisible 1 if you don't write anything to the exponent of 4. Then that is the end of it. I hope that makes some sense. Okay, maybe let me think of some more problems that I can add. What will be the problem number? It will be problem 9. Let's say this being problem number 9. Okay, maybe let's say we have 2 to the exponent of 2 over what if we have p to the exponent of 2? So you look at this one, then you focus on the bases. Are the bases the same? No, they are not the same. If they are not the same, there's nothing that you can do. There is definitely nothing that you can do because the bases are not the same. Then it means that's it. Nothing you can do, honorable member. So maybe another example. So I hope with that example, it opens your eyes in terms of what to look for and what to do once you have what you'll be looking for. Very, very much important, that part. So maybe one more example. Another example, let's say you have, it could be x multiplying, again, let's say x to the exponent of 2, and then we close this, we say to the exponent of 3. So what did I say? The first thing you focus on the bases. So those bases inside the brackets, are they the same? Yes, they are the same. If they are the same, then it means what you can do, it is to add their exponents. You have invisible 1 there, you were not given, but you know it is there if nothing is written. So you just write one base, then you have that invisible 1 that you plus it by 2. Everything else, you leave it as it is. So that means you still have your x. What is 1 plus 2? Definitely that is 3. And then you have that 3 on the outside. Then you end up having that exponent multiplying with that according to that rule. Then you have 3 that multiplies the 3. And lastly, you end up having your x to the exponent of 3 multiplied by 3. Definitely that should be 9, and that is the end of it. So can you see the laws are not necessarily complicated. Sometimes they can take that first law, combine it with the second law, or take law 1, combine it with law 3, or law 2, combine it with law 3, and then they ask you questions based on